In this lesson, I'm going to start doing experimental labs that you may come across while you're doing any physics course, any introductory physics course. So in this one, the objective is to use theory to perform the necessary calculations for a possible lab based on the topic of moments. And the experimental aim is to determine the mass of a piece of material using the principle of moments. So, two pieces of theory that we have to remember is what the principle of moments is. The principle of moments is that if a system of coplanar forces, and coplanar just simply means if it lies along the same plane, keeps a body at rest, then the sum of the clockwise moments at any point in the plane of the force is equal to the sum of the anticlockwise moments about the same point. And the next piece is that the moment of a force represented by the symbol T is equal to the force by the perpendicular distance from line of action of the force and towards the pivot. So let's do an experimental setup for it. We will first have a uniform rod suspended at its center. Now this uniform rod can be anything that as long as it is strong enough to support masses and long enough that you would have the ability to take measurements very easily. Most of the time when you're doing this in school, it will tend to be a meter rule, and you will suspend the meter rule or find the center of the meter rule by trying to balance it evenly. When it's balanced evenly, it's not supposed to fall off or topple or seesaw. Once you do that, you're going to have to find a mass that you know and suspend it at one point, a known distance away from the pivot itself. Once you have that known mass, it could be anything. It could be mass, a given metal mass, or pieces of plasticine, or any kind of material that you would need to use as a known mass. And then you're going to be given an unknown mass, and you're going to take this unknown mass and you're going to attach it at some point along on the other side so that it balances off these masses, this mass over here. What you're going to do is you're going to vary the distance of this mass here, and notice the distance you're looking at is the distance from this pivoting point here to the line of action of this force here, and you're going to manipulate this distance, which is why I label it as dx. You're going to manipulate this, and when you manipulate this, you're going to have to adjust the distance for the unknown mass as well, so that you'd be able to get a responding distance. Because of the principle of moments, you're supposed to be able to adjust this and get a corresponding length, and it will balance off. Now notice this is the manipulated distance, so I'll label it dx, and this is the responding distance, so I'll label it dy. That alone should tell you that right away you should be thinking of your x axis and you should be thinking about your y axis. The information that we have to get here is very simple, just the mass of the known, just the distance of the known, and the balancing distance for the unknown. We don't need this because we need to find this. We don't have to measure that. So what we're going to do here is we're going to analyze the experiment. First off, the force Fk produced by the mass Mk is equal to Mk by g, sorry. And this here is coming from the weight of a body that you already learned about. And the force Fukn produced by the mass Ukn is given by Mukn by g. Again, same equation, W equal M by g. Next, the force Fk produces anti-clockwise moments and Fukn produces clockwise moments, so you would see that they are going to be balanced on either side of the equation that you're going to use the principle of moments to develop. Remember, the total anti-clockwise moments is supposed to be equal to the total clockwise moments since they are balanced. So that means Fk is equal to d by x, and then we have Fukn is equal to d by x. Therefore, if we take this here and replace it with what we had earlier, we would see that mkg multiplied by dx and then mukn multiplied by g multiplied by dy is the new equation that we will have. Now we just simply make dy the subject of the formula since it's the responding variable, and we get dy is equal to mkg over mukng multiplied by dx. The g's will cancel off because they are the same value, and we will see that mk over mukn multiplied by dx is what we have comparing to the equation y equal mx plus c. Notice that y here is going to be the dx, the mk over mukn is going to be a gradient, and the final value of your x is just simply going to be a dx. So as I said, from this we can see that we need to plot a graph of dy against dx. We should get a straight line passing through the origin, because notice that c have absolutely nothing to map onto. The equation ends. And the line, as I said, the line passes through the origin, and the gradient will represent mk over m ukn. This here is an example of the sample data, and what I'm going to do is I'm going to show you how I would go about doing this. So first off, I would take the sample data that I have, this sample data here, and I would take it and put it on an Excel sheet. So this is my Excel sheet over here. This is my sample data in the corner over here. And I'm just going to simply take these values and plug it in here. So my dx is going to be 1, 2, and it goes all the way up until 6. And then my dy is going to be 2, 6, 8, 12, 13, 19. Now, these are not very good reading. You're supposed to get readings that seems to be regular in the changes that they have. This one here is not very regular. Alright, so I will take my information and put it over here. Once I get my information, I will select my information. I'll go to insert in my Excel spreadsheet, and I insert in a scatter graph. I'm going to take it and move it, right click, move to move chart to new sheet, and I get this piece of information here. Right away what I'm seeing is that I can have this scale right here. I can see that this here looks approximately to 2 centimeters on a x-axis, so every 2 centimeters I can put 1 unit, and this here looks similar to 1 centimeter or maybe 2 centimeters, and I can definitely put every 2 centimeters I put 1 unit. Alright, so right away I can have an idea as to what my scale look like. So when I go to do my analysis for my scale here, I can see that my x-axis range need to run from 0 to 6 from the table. So therefore that means I can use a 2 centimeter to represent 1 centimeter on that axis, because it has a lot of space available to double up or scale up the information. And on the y-axis range, I have 0 to 20 here, so we have that being a 1-to-1 relationship, because I only have approximately 23 or 24 centimeters on the y-axis scale. So both axes, as I said already, have enough space, so I ended up scaling up the y-axis values and leaving the I ended up scaling up the x-axis values and leaving the y-axis values as it is. The information I have here is done, and then all I need to do is start plotting my graph. So the graph information is here, and what I'm going to do is I'm just going to take the information and plot the points that I have. So let's look at some points. We have 1, 2. So 1, 2 is approximately here. Now this one is an easy one to plot. And then we have 2, 6. So 2, 6 is somewhere around here. Then we have 3, 8. So 3, 8 is somewhere around here. Then we have 4, 6. 4, 6 is somewhere, 4, 12, somewhere around here. Then we have 5, 13. 5, 13. Right here. Then we have 6, 19. 6, 19. Which is right here. Right away we're starting to see a little bit of a trend going in between here. We can see right away we will get a straight line graph passing straight through the origin. We can force it to go through the origin because we need it to go through the origin, since the information that we have for it has no intercept on the y-axis, as we saw for this here. We have no information on the y-axis here. The next thing I do once I'm finished plotting is I go back to the Excel spreadsheet and I take this information here and I tend to find the average of it. So the average of 1 to 6 of the information here equal to 3.5, and then I take the average of this information here, and I see the points 3.5 and 10. So I go back to my graph and I plot 3.5 and 10. So 3.5 is approximately here, and 10 is all the way up here. Alright, now that point there is the average point, and what I'm going to do is when I draw this line, I'm going to change this point to a little bit more of a brighter color so you can see it easier. Oopsie. Right, so you'd see that red dot there. So 3.5 again, 10, right here approximately. And then what I'm going to do is I'm going to just draw a straight line from the origin passing through that point. Now this red point that I put here, you shouldn't actually have it on your graph, but you should have a reasonable estimate about it. If the graph is passing through the origin, that means you know one point, and the average will be a next point that it should actually pass through. So I simply start from the beginning down here, draw a line that passes through that point there, and this case will be my best fit straight line. Now I simply identify 2 points on the graph, so I go on onto my graph page and I identify 2 points that are passing through the line. Sorry, I identify 2 points on this line so that I can determine my gradient. So the 2 points I am going to identify are ones that pass through across here, and as I start from one end and I come up here, I would see that this point here is across here, and I will just simply write this as a bigger spot in black so you can see it. So this point here should be across here. I can read that off from the graph, and if I go to the bottom of the graph and I start from the next side, this point here should be the other crosshair. Now I can find out the information about how much each graph is worth because right away I can see one unit has 5 little blocks, so I can find out how many little blocks it is and just simply divide. And I showed you all how to do this in a previous lesson, so I'm just going to go to the calculator really quickly and I can show you 1 centimeter divided by 5 little blocks means each little block is 0.2. So if I have 6 little blocks here multiplied by 6, that would mean that on this y-axis here this value should be at 1.2. And if I have 10 little blocks here representing this one on this axis, so I take my 1 divided by 10 little blocks, and each little block should be 0.1, and I have 1, I think it's 4. I have 1, 2, 3, 4 little blocks horizontally, so multiply that by 4 and I will have 0.4. So this point here should be 0.4 and this point here 1.2. And if I go to the next one, I can do the same thing, check out the little blocks and be able to get this value here. Now whatever value you get for your gradient, remember your gradient equation, y2 minus y1 all over x2 minus x1, and the coordinate that you get here, which is 0.4, and on the other end, which is 1.2, this here would be my first x1 point and this here would be my first y1 point, and the other one that I'll read off will be my y2 point and my x2 point and my y2 point. So once that information is done, I determine my gradient and I will get my value of m. Now what I would usually do after I plot my points and I am finished drawing my best fit straight line, or before I draw my best fit straight line, what I would usually do is I would come to this point here and I would simply go to my chart, then I would right click on my data, add a trend line so that it can calculate a gradient for me. I would simply set my intercept value to 0, make sure that that's 0, display my equation on my chart, and I see right here y equal this value here is my gradient. And I can zoom in on that a little bit so you can see. or in fact make the font larger, right? So this value here should be my gradient 2.9121. I can simply take 2.91 and use that, alright? So I have my gradient, and when I calculate my gradient from my graph itself, I'm supposed to get something very close to that 2.91, and if I don't, that means I did something wrong. Anyway, once you're finished getting your gradient for this question, if you look at the information on the chart itself, if you look at the presentation itself, you would see that here, mk over mukn is what the gradient is. So that means that value of 2.91 will be equal to this. So therefore, to find my unknown mass, I simply make it the subject of the formula, which would mean that my mk here, known mass, divided by my 2.91 is what will give me my value of my unknown mass. Now, look here, my known mass is 3 grams. So when I do the calculations with Excel, or I can manually do it, when I do the calculations, I get my gradient, which was supposed to be my gradient, which will be 2.91 when I calculate it from my graph, and my known mass, my mk, is a value of 3. All I simply have to do now, determine my mukn, comes from simply the equation here. So as I said, we take your mk divided by your value of your gradient. So that means my mk divided by value of my gradient, and in my case, my value should be 1.03 grams. Alright? And this is how you would obtain the objective for this lab. If you have any questions or comments, you can simply send them to me and I will answer any question that you have. Thank you.